Welcome to the video for C6.1.10 alloys. So before we start this lesson, you need to look back at your notes on C2.2.8 structure of metals if you've forgotten what we've done there. So you need to be able to describe metallic bonding, including drawing a label diagram, and you need to be able to explain the link between the metallic bonding and the properties of metals. So a quick revision of this. So metallic bonding is positive metal cations surrounded by a sea of delocalized electrons. And this diagram, if you excuse the crudeness of it, it's me trying to draw in paint 3D, and you know how awesome my drawing skills are. It should be something like a typical solid diagram, the sort of particle diagram that you drew in year 7. But instead of just the circles, you've got positives in the middle because each of those circles is a positive metal cation. And it's positive because the electrons in the outer shell have been delocalized, so they're no longer directly associated with the atom. They can move up and down. And this delocalization of the electrons means that metals are good conductors of heat and electricity. We can also make a link between this type of bonding and the high melting and boiling point. So metals, apart from mercury, we'd normally associate with having high melting and boiling points, and that's because there's a very strong force of attraction between the positive metal cations and the delocalized electrons. And because it's a strong attraction, it takes lots of energy to break it apart. So we have high melting and boiling points. You can see they're in nice, neat ordered rows, those cations. Because of the attraction between those positive metal cations and the delocalized electrons, that's strong enough that the layers of ions can slide over each other without breaking that bond. And that means that metals are ductile, which means they can be drawn into a long thin wire, and malleable, which means flexible. So before we start the lesson properly, there should be a slide in a second for you to answer some quiz questions, both on the last lesson that we did and the metallic bonding that we've just reviewed, and then you can continue with the lesson. So our learning objectives today are to list the elements used to make steel, duralumin, solder, brass and bronze, describe how the properties of alloys link to their uses, and explain how the structure of alloys is different from a metal element and how that influences their properties. So first of all, what is an alloy? So an alloy is a mixture of two or more elements, at least one of which is a metal. And you need to copy that definition into your notes. So we need to know what the makeup of some of the alloys and what they're used for, so you need to copy this table into your notes. This is directly from the textbook, so you can also see it from there. I'm not going to read that whole slide out. I'm just going to point a few things. So the important thing here is the link between the use and the reason for the use. So for example, if we take duralumin, it's used in aircraft parts. An aircraft, we always, when we're building aircraft, because they have to go up in the air, and they have to move very fast, the heavier they are, the more fuel they need. So you want a metal, you want a material that's low density, and you also want it to be very strong. So that would be why this alloy is used in aircraft parts. If we take solder, you've probably used solder in a tech lesson to use it to join electrical components. It can also be used in plumbing to do copper pipes as well. And the reason we use solder for joining electrical components is because it's got a low melting point, so we don't have to put a lot of energy in to melt it. And also it conducts electricity well. So this diagram shows the difference between a metal element and an alloy. So the one top left is pure iron, and that all the atoms in there are identical. So it's a bit of a simplified diagram. It hasn't got the positive metal cations in there. Otherwise, this diagram looks a bit of a mess. So it just shows the ions as just circles, like a typical year 7 diagram. So in there, you can see they're in nice, neat ordered rows because all the iron atoms are all the same size. So they're in nice, neat ordered rows, and they can easily slide over each other. When you look at steel, and we should know all about steel because the city we live in, when you look at steel, it's got carbon and other metals added. And because not all the atoms are exactly the same, then that means the metal ions, so the metal cations, are disordered. And that means the rows of ions can no longer slide over each other as effectively. And so it's not as malleable. So it's more brittle, it's more likely to break apart, but it's also harder and it's also stronger. So there's good points in that it's stronger and harder, but there's bad points that makes it less malleable and more brittle. So it depends what you want to use it for, whether this is a good thing or a bad thing. Right, now you've watched all the lesson content, you can answer the quiz questions on the new lesson content. This is not quite the end of the lesson because I'm going to go over a couple of exam questions as well. Right, so now you've done the quiz questions, we're going to look at some model questions. So there'll be a separate video on this, but I'm going to show you a link to a video which models how to answer the first exam question, and then you need to answer the second question, much like we've done in lesson before. So typical exam questions. This will be this is the question that's going to be modelled in the video, and then once you've watched how I would answer that one, you need to answer question 2. Either in written notes or document and email it to me. Okay, thank you for listening. See you next time.